Measuring segments. Please stop. Remember, a segment is part of a line with two endpoints. It stops. So we're going to be able to find the length of it. A line you can't find the length of because lines do what? Go on forever. So I can't find that length if it keeps going. A ray has one endpoint, but then it goes on forever. So we don't know the length of rays. We just find lengths of segments. Ruler postulate. We have two postulates today. The ruler postulate states that the points of a line can be put into one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. Distance is the absolute value of the difference of the corresponding numbers. Ruler postulate. Remember, postulate is just a fancy word for rule. Postulates don't have to be proven, bless you. We just accept them. So, what this is saying is that if I take a line and I have my points on it, okay, I can take those and put them on a number line. I can give them one-to-one correspondence with real numbers. Definitely not drawn to scale there. They're not evenly spaced. But I was able to take those points and put numbers with them. To find the distance between them, I take the absolute value of their difference. Jared, when you hear the word difference, what math do you think of? Subtraction. Good. So if I wanted to find the distance between A and O, from A to O, I would take the absolute value of their difference. See, Jared, there's that minus sign, right? Good. So then I take negative 17 minus 27 more. Anyone? 44, right? Good. Negative 44, and the absolute value of negative 44 is 44. Distance between 2 points. Find the absolute value of their difference. Subtract them. It wouldn't matter the order. If I went 27 minus negative 17, well, what happens when you minus a negative?
Add it.
You add it, and don't you still get 44 then?
Yeah.
All right. So the ruler postulate just says you can take points on a line, put them on a number line, and then find the distance between them. Sometimes they're really easy. The distance from J to N is what? 4.
4.
Sometimes you might have to do this math. Okay? Ruler postulate. Segment postulate. We'll see segment postulate a lot. What do you think we're going to do with the segment postulate?
Adding.
Add segments. Good. It states if 3 points, A, B, and C, are collinear. Madison, what's it mean to be collinear? On the same line. So we have 3 points on the same line, and B is between A and C. Then the length of AB plus the length of BC would equal the length of AC. Makes sense, right? Thank you. It should be. Okay. So if AB is 7 and BC is 9, then the length of AC is, I said that wrong. If AB is 7 and BC is 2, then the length of AC is
9.
9. Good. Do you notice how I have no symbols on those 3? When there are no symbols, that means the length of the segment. So we would write this and say the length of AB equals 7. Not segment AB equals 7. Don't want the symbol over it when you're talking about how long the segment is. Okay, that's just math notation there. Cool. Next vocab word. A coordinate is a point's distance and direction from 0. A coordinate tells a point's distance and direction from 0 on a number line. It's kind of hard to see them from the back. A is at -8, B is at 4. The coordinate of A would be -8. -8. Which part of that value tells me the distance it is from 0? Like -8. What part of that tells me how far it is from 0? The 8, right? Isn't it 8 away? Okay. Which part tells me the direction from 0? The negative tells me I'm on what side of 0? Left. 4, since it's positive, tells me it's on what side?
Right.
And the 4 indicates how far from 0? 4. Okay, number tells you how far. The positive, negative tells you the direction. Here again, to find the length of a segment, you take the absolute value of their difference. So we could take the absolute value of -8 minus 4 to figure out how far apart they are. Well, what's -8 minus 4? -12. Thanks, Devin. What's the absolute value of -12? 12. So the distance between them is 12. You can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you need to, count it. Double check with counting it. If your counting is better than your subtracting, then count it. It may not always work because, like I said, we might go to -84 to 322. That's a lot of counting to do. Okay. Congruent segments, next word down, are segments with the same length. Congruent segments, segments with the same length. That word congruent, you're going to hear it all year long.
Is this new stuff or?
I don't know why. Okay. Well, back in 4th grade, Devin, you did learn what the word congruent meant, but only you had it in relation to shapes. So you had similar shapes and you had congruent shapes. Similar shapes would be like a giant rectangle and a tiny rectangle. They're similar. Same shape, different size. Congruent shapes, big rectangle, big rectangle. Exact same shape, exact same size. So congruent means the same. They're equal. In this case, instead of doing shapes, we're not quite there yet, we're just going to do segments. No. Can I do more? Is that what you said? It was easy, wasn't it? Yeah, I know. All right, that symbol, the equal sign with the squiggle, that's the symbol for congruent. I won't write out the word congruent anymore. I'm going to use the symbol, so make sure you know what the symbol means. Okay, it's the equal sign with one squiggle on top. Right here, it says the length of AB is 2 centimeters, the length of CD is 2 centimeters. This sentence, math sentence, is read, the length of AB equals the length of CD. When there is no symbol on the top, then you're talking about the length. Okay. This next picture, AB and CD, I think you guys have 2 tick marks going through them, not 1, right? Those tick marks are how you mark congruent. So just looking at this picture right here, I know these segments are congruent because they have the same number of tick marks. This sentence would be read, segment AB is congruent to, I guess I'll write it one time, segment CD. Okay. Length when there's no symbol, segment when there's a symbol over it. Capiche? Well, blank is congruent to blank. Which one matches this symbol to go in your blanks? Don't you have blank congruent to blank? So that goes in your blanks. AB is congruent to CD. That says AB is equal to CD. Are those the same sentences? No, they're very similar, but they're not quite the same. One's talking about length. Length is a numerical value. One's talking about congruency. That's the actual picture then. The congruent symbol. Okay, I have all these segments. Looking at those markings, I would know that segment AB and CD are congruent. They're the same length because they both have one tick mark. EF, GH, and IJ, these three, would be all the same length because they have 2 marks. KL, it's not congruent to any of them. Okay? So the tick marks tell you which segments are congruent to which segments. Isaiah? No. Congruent, same length. Next week we'll talk about congruent angles. They'll have the same measurement. Midpoint, last vocab term here. A midpoint is a point that divides a segment into 2 congruent segments. Midpoint, it's a point that divides one segment into 2 congruent segments. Jared A. The midpoint would have to be found right in the what? Are you Jared A too? You're Jared C. Sorry, Jared C. Jared A. The midpoint would have to be found right in the... Good, excellent. I was staring at him the whole time, so that's how to read it. Good. Right in the middle. So if B is right in the middle of A and C, wouldn't it make sense that the left side should be the same as the right side? Yeah, right in the middle. Anna, if AB equals 4, what's BC equal? Good. And Anna, then what would AC equal? Did you know you just used your segment addition postulate to get that? Because you added 2 segments to get a third one. Nice, huh? Okay. Example 1. Sometimes you do, though. Find the length of AB and the length of BC, and then it asks if they're congruent. I want to know the distance between A and B, and then the distance between B and C, and then decide they're congruent. Just do this quietly on your own paper right now. Count it if you need to. Make the little loop-de-loops. If you have more confidence in your counting than your subtracting, then do the counting. Kutzmick, what'd you get for the length of AB? How about BC? Would you say they're congruent? Good. Math sentence, segment AB, not congruent to segment BC. You don't have to today, but we will eventually this year. The slash through it means not congruent. You know, like no smoking. It's got a slash through the sign. Right, Cade? Yeah. So this actually would be read, segment AB is not congruent to segment BC. Kutzmick, why aren't they congruent? Exactly, because they're not the same length. Number 2, if the length of AB equals 25, find the value of x, then find the length of AN and then B. Value of x, that should make you think algebra. Algebra, hopefully you're thinking equations. So you have to look at the picture and the information they give you and set up an equation to find the value of x. You have to set up an algebraic equation based off the information they give you. Isaiah, did you have an equation? 2x minus 6 equals x plus 7. Isaiah, why would you say that these 2 segments are congruent? Huh? They both add up to 25? So does that mean that they're congruent? No, so what should we do to fix our equation? How so? Well, then you're telling me that this is a length of 25. Okay, do you want to phone a friend? Here, ring, ring, I got it. Chris, he called you. Can you help us with this equation? Oh, good.
2x minus 6 plus x plus 17.
Excellent. Quinn, Anna, this is that segment addition postulate. AN plus NB equals AB. Right, Isaiah? Wouldn't the little segment on the left plus the segment on the right equal the whole thing? Okay, and then I just took what we knew and substituted it in. Actually, Chris did that for us. Okay. Chris, help us finish this, please. Okay. Now what? So 3x equals, divide by 3 and x is equal to? Good, Chris, thank you. Boy. I pulled your popsicle stick. Chris said that x equals 8. Are we done with our problem? No, because I still have to find AN and NB. How are we going to find the length of AN? Oh, that's why what do you mean? It's 2x minus 6. Chris told us 2 times 8 minus 6, right? Do you remember what 2 times 8 is? And 16 minus 6 gives us, no, you were right the first time. 10. 10, yep. 16 minus 6, that's 10. Yeah. Thanks, boy. Can you find me NB too? If NB is x plus 7 and x is 8, what's 8 plus 7? Yeah. Anna, does that make sense with the segment addition postulate that 10 plus 15 would equal 25? Yeah, it would. Algebra, remember we talked about on day 1 and 2, you can check your work. You're using algebra with geometry here. So when you go to check it, now you have to think, does this make sense? That 10 plus 15 would give me 25. Okay, does this make sense? Is it logical? Example number 3, we're at the bottom. M is the midpoint of segment RT, and we're supposed to find the length of 3 segments. Cam, M is the midpoint. What do we know then? Awesome. Segment RM and segment MT are congruent. Practice marking your pictures with those tick marks. Eventually, you will be required to mark your pictures, so we're going to practice during notes. Those tick marks mean RM is congruent to MT. Sydney, if those segments are congruent, what equation can I set up to find X so that I can find the length of each of them? Good. 5x plus 9 equals 8x minus 36. They're congruent. What's it mean to be congruent? The same. So shouldn't I set them equal to each other? Yeah, because in math, same means equal. Sid, help me finish solving this. So then I get 9 equals 3x minus 36. Now what should I do? How should I bring it over there? Good. 36 plus 9, Sid? 45. Good. What's the last thing I need to do, Sid? Do you know what 45 divided by 3 is? 15. Good. Boy, was that you? Did you whisper 15? Yeah, nice. Boy, are we done? Did it just say find x? Well, there's no x actually in this sentence, so we're not done yet. Okay, we still have to find the length of RM and MT and RT. That's going to be like the most common mistake, forgetting to like follow all parts of the question. Sophie, how do I find these lengths? Okay, what's 5 times 15 plus 9? I'll give you a hint. 5 times 15 is 75. 84, good. RM, the left side is 84. Sophie, what's MT then? Why? MT is right here. What? Good, it's 84 because they're congruent. And now Sid, we have to, sorry, not Sid. Sophie, we have to find the whole length. So what should I do with those two numbers? Good, 4 plus 4 is, and 8 plus 8 is, there you go, 168. Mind blowing. All right, flip it over. All right. Devin, number 4. What'd you get for the length of AB? 5. Good. And then Devin, where did you put C on the number line so that AB and BC were the same length? Good. At 3. That's where you want to put C. When you count this, 1, 2, 3, 4, 5. The length of 5, so you need to go 5 more so that they're congruent. Good, Devin. Number 5, EG equals 100. Find the value of X, and then find EF and FG. Dalton, how'd you start this one? Okay, give me your equation. Excellent. This is your segment addition postulate. EF plus FG equals EG. Braden, whoop, help me simplify this down. Which would get me to what? Now what? So then I get 6x equals, divide by 6, and x is equal to? Awesome. Boy, got good math skills. Oh. Riley, are we done yet at x equals 15? Okay, what should I do to find EF and FG? Okay, what's 2 times 15? Plus another 30. So FG equals 60. Riley, if the whole line is 100 and this is 60, how much is over here? Good. You should still get 40 if you plug it into x too, but that's just another way to find the rest of your segment. You sorted us? Okay. Number 6, Z is the midpoint of segment XY. Macy, what's it mean if Z is the midpoint? Good, it's right in the middle, so XZ would have to be congruent to ZY, correct? You can use 1 tick mark, you can use 2 tick marks, it doesn't matter. You need to have some on there. XY, the whole length is 27, and they only want us to find XZ, the left portion of it. Amanda, how are we going to figure out the length of XZ? Right, because we cut it in half, right? Yeah, what's 27 divided by 2, Amanda? 13.5, good. Midpoint's right in the middle. It's got to be equal on both sides. That's that logic and common sense we have to remember. Middle, equal on both sides, right, Cade? Good. All right, we're going to go down to 7, part C. Okay, it says, suppose that T is the midpoint. Do you see how I have the word suppose there? Because when you look at the picture, does it look like T is in the middle? Oh. No, so that's what that word suppose is telling us, that it doesn't look like it, but I want it to be the midpoint. If it's the midpoint, Macy, what do we know about the two segments? Good, mark them congruent. Even though they don't look like it, the markings tell us they have to be congruent then. It just is. Just what happens.
That's dumb.
What?
Will that happen?
Yeah, there's a lot of times I don't draw things to scale, so you have to go based on the markings of it. And I'll get there when it happens. All right, so then it says to find the value of x when xt is 2x plus 11 and xz is 5x plus 8. I'm going to give you a minute here, or two.
Why are we incorrect
Mm-hmm. Okay, so when you label your picture, xt is 2x plus 11, xz is 5x plus 8. Oh, geez, Louise, what's 5x plus 8 representing?
XZ.
The whole thing, right? So would it make sense to set this chunk equal to the whole thing? No, we got to figure out what the other chunk is. Tana? Good. The other chunk would be 2x plus 11 because they're congruent. So Quinn, then what would I do? Yeah, 4x plus 22, because 2x plus 11 plus 2x plus 11 would equal 5x plus 8. It takes two of those 2x plus 11s to get your total. Subtract 4x, subtract 8, and you get x to be 14. Make sure you read and label carefully. That's your answer. Oh, we only needed to find x on this one, so then we're done. Alyssa, way will get you the same answer, right? Okay. Here's your homework.